So in this lesson, we're going to learn about applications, and we're going to start back with an Algebra 1 application of linear equations. So when you read this, it says, read each real-world equation situation carefully and define the input and output. That's one of the most important things with real-world problems, because inputs and outputs, they're not X's and Y's. I always tell my students, look, you don't have yaks and xylophones in a real-world problem. You have time, you have temperature, you have volume, you have area. So make sure you're defining those, and we'll go through that in this problem. Okay, so in this problem, we're talking about linear functions, and we're going to also find an inverse while we do it. So when you do word problems, please remember that word problems are they're not an intelligence test. They're really something you have to be trained to do. And in this case, the question is, what things do you think about when you have linear functions? Hopefully, the first thing that comes to your mind is y equals mx plus b. But there's another equation that's important. That's y minus y1 equals m times x minus x1. And they have names. The first one is called the slope-intercept equation because you need a slope and a y-intercept to use that equation. The second one is called point slope because the x1 and y1 are used with slope to find a model. Both of these require you to find slope, which if you remember is y2 minus y1 over x2 minus x1. So now that we reviewed that, let's take a look at our example. So the example is the BK gaming console charges one customer $69.20 for playing 82 hours, while another customer is charged $88.40 for playing 114 hours. It's very important in this case to think about input and output. So the way that you do that is to remember the concept of independent and dependent variables. And that always threw me off when I was a student. Independent means input. So just remember independent input. And also remember that independent variables control the dependent. So ask yourself, is your bill of $69.20 controlled by 82 hours? Or does 82 hours control or produce this bill? And the answer is the hours you play cost you money, not the cost makes 82 hours. And in general, unless you're talking about advanced level physics, time is almost always independent or input. So just to review, independent means input, independent controls or produces the dependent variable. So in this particular problem, we are going to want to write, right? We're going to want to write out our independent and dependent or input and output values. Input, as we said, is time. I'm inputting this many hours, and it's costing me this many dollars. Once you do that, you can transform the $69.20 and 82 hours into a point, right? So when you look at this, the $82, right, is making the $82 is making 82 hours is making $69.20. That time is producing that cost. You can clearly see the independent making the dependent. And the other point is 118 hours is making a cost of $88.40. Notice that when you do this work, you don't worry about the units. Once you do that, you can easily use the slope equation, right? This is x1, this is y1. And then you can take those values and just use the slope equation, y2 minus y1 over x2 minus x1, and just plug stuff in. y2 is $88.40. Y1 is $69.20. Okay. Then remember what I said, that the output value always has what makes it below it. So $88.40 is made by 114, just like we did at the beginning of chapter 1. And $69.20 is made by 82. So just make sure that they're linked vertically. Then you can reduce that by using Desmos. You can see here that I got 0.6. So when you use Desmos, one of the things you need to understand about how to use division is if you just try to type this in, like if you just try to type in 80/40 minus 69/20 and then try to hit divide, it'll do that. And that's not what you want, right? So there are two ways to do that. One way is to highlight the whole thing and then use the division symbol or backspace key on your keyboard, which is right next to shift, and then type in 114 minus 82. And that's how I got 0.6. The other way is to use a parentheses and do 88.4 minus 69.2. and then go to the very edge of that. Make sure you're outside of the parentheses and either use backspace or use division. You will get the same answer. So the hardest part about typing that into a calculator or Desmos is getting it to look like your paper. So once you have that, please keep in mind that that is called the rate of change. And sometimes on the SAT or PSAT, that is all you need in the problem. It'll literally say, what is the rate of change, and identify the units. The units on rate of change is output per input. So if that was the question, it would be $0.6 per hour. I got that from right here, output divided by input. But this equation wants me to write a model. So I have my rate and I have my point slope. So all I have to do to use point slope is put the rate where the M is, put the X1 where the X1 is, put the Y1 where the Y1 is, and that's my point slope equation. To transfer a point slope, right, to take this point slope equation here and transform that into slope intercept, I would have to distribute my rate, simplify that, and then solve for Y by adding $69.20, and I would get slope intercept. Now, one of the things I really focus on with my students is it's really not good to leave it like this, because we have up here that our input is time and our output is cost. Down here, we're talking about yaks and xylophones. So we would want to change the Y into C and the X into T to make it make sense in this problem. This thing right here is function notation, and it would be read cost with respect to time, very important for later math or physics classes. And this rate here would then be always connected to the independent variable. This, as you recall, is the Y-intercept. When you go back up here and look at this equation, the B is the Y-intercept. So the Y-intercept is sometimes asked for in a word problem that is called initial value. Not important in this problem, but it can come up in other problems. Okay, so then the part B just says, hey, now that you've done all that work to get your model, and by the way, getting your model is the hardest part of a word problem. Sometimes they give it to you, but not normally with linear functions. They want you to be able to find that using the three linear equations. Again, slope intercept, point slope, and slope. So once you do that, this problem just wants you to put 200 in the right spot. And so when you think about 200, you really need to think about 200 hours. Is that cost or is that time, right? So you need to put it in the right spot. And a lot of times, a lot of word problems, that's what it's really about, is just knowing what you have and where it goes. So the 200 hours goes in the time. I put it right there where the time is, and then I calculated that using Desmos, and then I put a unit on it. It's talking about cost at 200 hours, that would be $140. I mean, if you played this video game system for 200 hours, it's going to cost you 140 bucks. All right, part C asked me to do an inverse. When you do inverses, you have to understand something about how you probably learned this originally. An inverse means to switch X and Y and solve for Y. Well, we don't have X's and Y's anymore. And the real thing you were doing with X's and Y's was just keeping it straight. You could have solved an inverse by simply solving for X and then rewriting it as the inverse. But we teach you to do switch X and Y so you can keep it straight, because you knew how to solve for Y when you first came into Algebra 2. So when you solve this problem for the inverse, you don't want to switch C and T, you just want to solve for T. And that's going to involve reversing the order of operations. So you start at the bottom of the order of operations and you're going to add or subtract. Then you're going to divide by 0.6, but you want to make sure you know the rate of change of the inverse and the Y-intercept. So you're going to want to divide each piece and simplify that on a calculator. You can see that 1 divided by 0.6 is 1.6 repeating, and then negative 20 divided by 0.6 is negative 33.3. So I reduced that. Use 3 decimal places. AP classes and SAT, they like 3 decimal places. And then I just rewrote it as T of C. Okay, and so there's my inverse. And then it asked me to then take this $100 and put it in the right spot in the inverse. Now, just pay attention to the unit. You see how it says dollars? That's going to go in C, and then you're just going to type that again in the Desmos. When I typed that in, I got 133 hours, meaning someone gives you $100. How many hours can you play? So just as a review, when you see the word linear, you need to be using one of these 3 functions always. You need to identify independent or dependent variables, You need to make sure that you're keeping track of it all. Most importantly, are you making points correctly? Notice that the points are written backwards in the problem. This is a routine thing that is done on SAT or PSAT questions. They put the dependent and then the independent, very frequent. Then you just find slope, you use your equations, and at that point, you're just plugging stuff in. I hope this was helpful, and I hope that you learned something about linear equations and word problems.